Oh, hi, welcome back. So today we're looking at how to find the roots here. We're going to use our rational zero theorem that we have and that we've been using, and we're going to find the possible list, and then we're going to identify which ones they are. Now, polynomials that we're working on has a leading coefficient of 1 today. We're not going to use, we're going to have other methods for when the leading coefficient isn't 1. So here we go. We know these leading coefficients are going to be 1, so we're going to have integer type of zeros, and so it's all the factors of 20. So our zero possibility is going to be all factors of 20, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. 1, 2, 3, 4, 5, 6, 12 possibilities, knowing that the denominator is 1, because that leading coefficient is 1 and has a factor of only plus or minus 1. So we have that as a list of zeros. Which zeros work? Well, here's the method that we use when this leading coefficient is 1. We're going to do what we did last week in the last lessons, where we use synthetic division to be able to find zeros. So we know it's either going to be plus or 1. One of these 12. So let's just start with 1, use synthetic division. To follow a process to see, and again, what's the test we learned last week for it to be a root? It would have to, the remainder would have to be 0. This last number would have to be 0, and if that's the case, then it's a root. Let's see. 1 times 1 is 1. Negative 7, negative 7, 4, 4, 24, not a 0. So we can eliminate the positive 1. Well, what about negative 1? We go through the same process again. Negative 1, negative 9, positive 9, 20, negative 20 adds to 0. Ding, 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 ding. Negative 1 is a root. So we know we have a factor now. So now we know we have a function that has that is f of x equals this root, or x minus that negative 1, leaving this answer. This is all stuff we did last week as the second polynomial. Well, knowing now that that's what the function looks like, we want to see if there's factors, or we're going to use a quadratic formula since this is a quadratic polynomial. We could use either one of those methods that we practiced last week to find the other x or the other zeros that this polynomial happens to have. So we're going to set it equal to 0. I see that this factors very nicely for me. So it's x minus 4 and x minus 5. That's what multiplies 20 and adds to 9. So that's how I factor, setting it equal to 0. Then we find our zeros for this particular polynomial to be the negative 1 that we first initially found, and then this one's going to be 4, and this one's going to be 5. Again, doing what we did, setting those 3 things that are being multiplied equal to 0. All those 3 things you can set to 0, solving each, you find those solutions for the zeros of this particular polynomial. Now, that's how you, without being given any of the zeros, like last week, we now found one using synthetic division because we had a list. And we knew of those 12, 1, 2, 3, 4, 5, 6 times 2, 12 possible roots, or zeros, we found the 3 that were real. Now, are they in the list? Is negative 1 in here? Yes. Is 4 in there? Yes. Is 5 in there? Yes. And so we knew we had a finite number. We didn't have an infinite number of numbers to choose from to find where the roots are, those x-intercepts, those solutions for this polynomial. We found it through whittling those infinite number of choices down to just these 12, and then use synthetic division to make it a shorter process of being able to find those roots. So that is how we use it. That's the method that we're going to be practicing to find these zeros when this coefficient is 1. We are the Ask Academy.